Hello, everyone. Mr. Minnick's my name. Math is my game. I'll say that again. Mr. Minnick's my name. Math is my game. And today I'm joined by my fifth period Algebra 2 class. They're so excited to be here. This is their first time recording a lesson, and today's lesson is on tackling whatever this word means. That's a big word, that second word. If you look at the prefix of it, what's the prefix BI mean? Two. Do you guys know why the bicycle fell over? Because it was too tired. The bicycle fell over because it was too tired. Okay. All right. So when you see the word bivariate, you're probably thinking to yourself, I'm in for a world of trouble. The number one problem people have with math isn't that they can't math. The number one problem people have with Spanish isn't that they can't Spanish. It's they don't get the language. Suppose you're from a foreign country and English isn't your first language. Just getting used to things is going to be difficult enough, right? And that's what happens in math. You see all these words and you're like, dude, I don't know what that means. So the word bivariate just means there's two of something. If you look at the root word, vary, we're talking about variables. So there's going to be two variables. One of them is going to be an X, one of them is going to be a Y. And in today's example, what we're going to be looking at is shoe size, and height. Shoe size and height. Now the shoe sizes, we're going to be putting these shoes, we're going to be, in the first period class when I did this, I came up with 6 names and I can't even remember them, and the names are irrelevant. But I think I had some guys wearing some girls' shoes just to make everything uniform. But we're going to be looking at data for women, okay? So these are all going to be ladies. These are all going to be ladies. So all the shoe sizes will be given in women's shoe sizes, and the heights are going to be given in inches, okay? So we're not going to say that somebody is 5'10". We're going to say that somebody is 70 inches tall. We're not going to say somebody's 8 foot, or what, 6'10". We're going to say somebody's 82 inches tall, okay? So all the heights are going to be given in inches, and all the shoe sizes are going to be ladies' shoe sizes. Is everybody with me so far? Okay. So I've got some data, and like I said, the names are irrelevant, but maybe we will put names with people. Do you want to? You want to put names with these people? Okay. So what we need to figure out before that, though, is just a real quick thing. Anybody remember in the Cartesian plane what axis, the one that goes horizontally, is, the X or the Y? That's the X-axis. Good. Everybody brought their A game today. So the other one's the Y-axis. Now, one of those is called the dependent variable, and the other one's the independent variable, right? The independent variable is the one that happens regardless of the other one happening. And the other one is contingent on the other one. The other one depends on the other one. Let's see, dependent, yeah, I wrote that right. Does anybody remember which one's which? Which one the X is? Independent, nice, good. So the X is the independent and the Y is the dependent. So we're talking about height and we're talking about shoe size. So let's think about this. We're talking about somebody's height and we're talking about somebody's shoe size. What do you think we should make the independent variable, height or shoe size? Height? Okay. So if we say that the height is the independent variable and the shoe size is a dependent variable, the question we're going to be asking is, as someone gets taller, do their feet get larger? Is that a reasonable question? Heck yeah, it is. And that was an excellent choice of the variable. You're welcome. So let's go ahead and look at that. Let's think about something. Suppose a baby is born. You know, one thing I don't understand about babies, and I probably shouldn't comment too much, but when people talk about having babies, they said, oh, they're having a little baby. Of course they're having a little baby. That's what babies are. They're little. Oh, what'd they have? They had a little girl. Of course it's little. It's a baby. Anyway. So somebody's born. They're not very tall, and they don't have very big feet. Right? And then what happens for the first few years? You grow. And your feet get bigger and you get taller. And then what happens in 7th grade? Because you're starting to eat a lot of chicken with GMO in it. Your shoes grow like you don't get that much taller, but then your feet you go like from wearing size 7 shoe to size 15 shoe overnight. Right? And then what happens? Then your feet don't get any bigger, but you get a little bit taller. That's kind of weird the way that happens sometimes, isn't it? So that's if we were to put height and shoe size there and there. Now I want to turn these things to purple. Not fade to black, but I want to turn these things to purple. And I want to look at this same situation again, but this time I want to suppose that we put, oh man, I didn't want to make that last one purple. I want to make this height purple. There we go. Properties, purple. There we go. Okay. So suppose we look at this in a different light. Suppose now we consider this being shoe size, and this being height. Does it make sense to ask this question as somebody's feet get bigger, do they get taller? Does that question make sense? Not as much, but it kind of makes sense. Let's think about this. What happens? You're born, and your feet aren't very big, and you're not very tall. But as your feet start to grow, guess what? You get taller. And then what happens? Then, all of a sudden, your feet get much bigger, but you don't get any taller, right? So it kind of does something like this. Right? Your feet get much bigger, but you don't get any taller. And then what happens? Your feet stay the same, and you get taller. Dude, wait a minute. We ended up back at the same place, didn't we? So does it really matter which way we put the variables? In this context, we could put them either way. But honestly, I think that making height the independent variable makes the most sense in the context of the problem. Would you agree with that? Good. Okay. So we're going to name names. We're going to look at these ladies. This one lady is 72 inches tall, and she wears size 12 and a half shoe. 72 inches tall. You know how tall she is? That's 6 feet. That's a big lady. In my first period class, I think this was actually a guy that was wearing girls' shoes. Okay. But what's her name going to be? She's 6 foot tall, and she wears size 12 and a half shoe. What do you want her name to be? Beatrice. Can we call her B for short? B. Beatrice. Okay. There's another lady who's 65 inches tall. For those of you that don't know, that's 5'5", and she wears a size 8. What's her name? Shelby. Thank you. Shelby. All right, then we got this other lady. She's very, very tall. This is actually my high school ex-girlfriend. Her name was Rebecca. She was 6'2". Actually, she was 6'3" and a half. She was a little taller than she had a little bit smaller feet, but I dated a girl in high school. She was 6'3" and a half, and she wore like a size 11 shoe. She was big. I know. So we'll call this one Becky. That's my high school girlfriend. Okay. Then we got another lady who's 5'8" and wears a size 9. I think we called her in the first period class. We called her Joan of Arc, actually, I think it was. But the names are irrelevant. And then we have somebody who's 5'11". I'm not going to name names, but this was actually a young man in my other class. Somebody who's 5'11" that wears size 13. And we mixed and matched them. And then lastly, we had somebody. We'll call this person Charlie. And then this other person, 82 and 17. We'll call her Chantel. Chantelet. There we go. She's French. She's a model, probably. I don't know how she'd do walking down the runway, but so this is our data set. Notice that we have two variables. We have x1, x2, x3, x4, x5, x6, right? And we have y1, y2, y3, y4, y5, and y6. Now here's the part where we're going to start using the calculator. We want to take this data and we want to put it into the TI NSpire. You ready to do this? Okay. I know you were born ready. So the first thing you want to do is on the calculator, you want to go home. You want to start a new doc, and you don't want to save, you don't save the other one, the old one. Now, if you're not sure what I'm talking about on this TI NSpire, you'll notice there's 6 buttons at the top. They're awesome buttons. They're great buttons. You see these 3 on this side and these 3 on this side? This one up here, the home button. It's also the on button. We're going home, new document. What button could I press to access new document? I could press number 1. Do I want to save the unsaved document? No, I don't. I'll leave that up for somebody else. Now, we're trying to take this data and organize it. Thank you, spreadsheet. Nice, good. So option number 4, we're going to add our lists and spreadsheets. Everybody with me here? Add our lists and spreadsheets. Whoop. Now, I don't know what you know, but I know that right next to cell A at the very top column, if I go all the way to the top, do you see how there's a little tag next to the A? You know what that tag stands for? Not variables. Let's think about it. You go to the clothing store and you want to buy something. You want to know how much it costs. What do you look at? The price tag, the price, it's a label, right? So we're going to put our labels in here. Column A normally represents our X variable. What did we say our X variable was in this context? Someone's height. So let's go ahead and type in that cell. We're going to type in height, H-E-I-G-H-T. The keyboard on this calculator is very awful. It's an ABC keyboard. You're going to hate it, but get used to it. Once you have that, you can go ahead and press enter. And guess what we're going to do in the column right next to it, in the cell right next to that? Shoe size. Now, there's probably not going to be enough room to put the whole word shoe size, let alone the space. So can we just put S-I-Z-E size? Is that fair? S-I-Z-E. Everybody good with that? Who remembers being 5 years old? Anybody? When I was 5 years old, you know what my dad said? Whatever you do, don't put your finger in a light socket. So guess what I did? I put my finger in a light socket, and it shocked the crap out of me. And it hurt. And I did it again, and the same thing happened. I had to find out. I had to do it twice. Maybe a couple years later. I might have done it a third time a couple years later. Anyway, do you see these cells next to the equal sign? What'll happen is if you inadvertently type something in there, potentially hyphens could generate on their own. If hyphens generate on their own in these other cells, that's very bad because they generate infinitely all the way down the column. And if they're there, they're going to screw up everything else. So what I'm saying is don't type anything in the cells next to the equal sign. All right. Starting with cell A1 then, do you see all of our X values, the 72, the 65, the 74, and all those? We're going to enter those in that order, okay? So what was our order? Is that right? The 72, 65, 74, everybody see those on the chalkboard, on the dry erase board? Go ahead and enter those in that order. 72, you can press enter after each one. 65, 74, 68, 71, and 82. Everybody got them? Now, if you haven't figured this out yet, what we're going to do in column B, starting with cell B1, we're going to go ahead and put in the Y values, the shoe sizes, starting with the 12.5. Notice that our 72 and our 12.5 are mated or paired up. The 65 and the 8 are paired up. The 74 and the 12 get paired up. The 68 and the 9 get paired up. The 71 and the 13 get mated, and the 82 and the 17 get paired up. Has everybody got their pairs in? Are you working on it, I hope? This is the hardest part of the whole thing, just putting the data in. Make sure you get it put in right. After your last one, make sure you press enter. We doing all right so far? Okay. So just so you know what's going on. So we started a new document. We inserted what, a lists and spreadsheets page? list, spread, sheets. We label columns A and B, and we enter our data in cells A1 through B6, right? So far, so good? Got all of our data in there? Any questions up to this point? Any comments up to this point? I should probably pause for a little bit of comical relief. Does anybody know what happened to the magical tractor? It turned into a field. The magical tractor turned into a field. Okay. So now what we need to do is we're going to do something with this. We want to look at this. Sometimes you just got to look at it. Now, when I speculated about this thing before, about what would happen, we kind of made this two-dimensional graph in the Cartesian plane, if I could get back there. I have no idea what's going on with my smart board. It's saying, Mr. Minnick, you suck. It's saying, I'm not going to cooperate with you. It's saying, I really didn't appreciate your tractor joke. So whatever you do, don't tell me any more jokes today, because they're bad. So we're going to graph this thing on the two-dimensional plane, right? But when we're analyzing data, we're not going to add a graph. What we're going to do now into our document is we're going to insert a special kind of page. Not a graph page. We're analyzing this information. We're analyzing this bivariate. What? This bivariate data. So this is going to be data and statistics that we're going to insert. We're going to insert a data and statistics page into our document. So let's try this. How could I insert something into my document? Where could I go to find an important button? A menu is not a bad choice, but there's one that makes a little more sense to insert something into the document. Doc. I'm going to my doc, and I want to insert. So option 4, insert. And I want to insert a data and statistics page. So option number 11. How do you like that? Did you guys make it there all right? I'm going to give a shout out to Dylan Wilson. You guys know him? Dilson Wilson. Now, the calculator is asking me to click down at the bottom center to add the variable, right? I don't know how you guys' fingers are, but I play the guitar and I have calluses, and my fingers don't work well on a mouse pad. That directional pad is just like a mouse pad. What you need to do is you need to put the cursor down here. Or you can press a button. Shout out to Dylan Wilson for teaching me this. Do you know the tab button? Do you see it? Press the tab button, and it automatically jumps down to this bottom center. What variable do we want our independent variable to be? What variable do we want our independent variable to be? This one down here. Height. So we'll go ahead and select height, and watch what happens. Do you see all the points fall into line? Isn't that just the bee's knees? Isn't that the cat's meow? Well, guess what? We're dealing with bivariate data, so guess what we got to do now? We got to go onto the side. What could we press to go onto the side? Tab again, sure. Press tab again. Now I'm going to have to click it here because my computer does not play well with my smart board, does not play well with my calculator. And what variable do I want to make that one? Size or shoe size. And watch what happens to the points. Ah, there they are. Isn't that cool? Now watch what happens if I switch these around. Watch what happens if I switch these around. Do you see the points don't mix that much? But we wanted height. We wanted what? Height down here and shoe size up there. How's everybody doing so far, okay? Suppose we were making a scatter plot out of, oh man, they keep swapping. We made a scatter plot. What kind of correlation exists here? Positive, nice. So in other words, we could say as somebody gets taller, chances are their shoe size is going to increase. Does that make sense? Good. Well, we're getting there. What we want to do now is we want to insert no, we don't want to insert. I'm sorry. We want to run a linear regression from the lists and spreadsheets page. From the lists and spreadsheets page. Oh my gosh. We want to run a linear regression from the lists and spreadsheets page. I don't even know what he's saying. It's kind of like when people use certain words in the English language. There's some words in the English language that just don't make any sense. Like pumpkin. Pumpkin only has one in it. How come everybody says pumpkin? There's only one N in it. And there's two P's in it. Everybody says pumpkin. Or what about that drink with the red cap on it, or the blue cap, or the pink cap sometimes? Milk. Or what about that stuff with the lid on it that you put on your desserts in place of ice cream? The stuff that you can make all kinds of desserts on. It's usually vanilla or like a white color. They make it extra creamy. The whipped topping, the cool what? Cool whip. Okay. All right. So what I'm trying to tell you is I need to get back to the first tab on my calculator, right? How on earth do I do that? I do what? You click 1.1. So if you're able to move your cursor over to the 1.1, you could do that. There's another way to get there. You could hit Control. You could hit Control and then use the D-pad, and you could get there too. The Control button is right below Tab. How you guys doing so far? All right. Now, when I took an English class, the best bit of advice that my English teacher ever gave me was, whatever you do, don't use a highlighter when you take notes in college. Because you know what happens? You highlight every page of every book, of everything you read. But in this context, what we need to do is we need to highlight both columns. We need to highlight both columns. And doing that is kind of tricky. What you're going to do to highlight both columns is you're going to arrow up and up and up. Why did you say up and up and up? You'll see in a minute. So you're going to arrow up and up. And you get all the way to the top, and it doesn't matter if you're in cell A or cell B, but be in column A or B, one of the two. And I'm going all the way to the top, and it didn't highlight jack squat. I want to highlight the whole column. So did you see how he said, right, arrow up and up and up? I'm going to arrow up one more time and watch what happens. Arrow up. Do you see how it highlights the whole column? Isn't that cool? So what you need to do now is you need to press S-H-I-F-T. That's shift, and then arrow over. And that'll highlight the other one too. Okay? So we've got the one highlighted. We're going to press shift. Do you see where shift is? Right above the 7. Shift and over. It highlights the other one. You got that going on? Okay. So now I feel like I'm at Wendy's. I don't like Wendy's because you get a hamburger and it's cold. And you ask them to put extra mayonnaise on it and they don't put any mayonnaise on it. I hate that. Mayonnaise what? Mayonnaise is bad? I almost died because of mayonnaise. True story. I used to joke around and say that mayonnaise is going to kill me one day. Last year in October, I had to have my gallbladder removed because of mayonnaise. I love mayonnaise. I put it on everything. I dip my pizza in it. Miracle Whip. I prefer Miracle Whip. There is. Big difference. Yeah. Okay. So what we're going to do now, to run this regression, I'm at Wendy's. I don't know what to get, so where do I look? The menu. It's one of those 6 buttons. It's real important. I press menu. Now, we're trying to run a linear regression. That's a statistics idea. So we're going to go option 4. Well, not option 3. We're actually going to go option 4, statistics. And we're going to go with stat calculations. And do you see where it says linear regression mx plus b? That's the way. I like it. Do you guys know that song? That's the way. Okay, so we choose this linear regression option. If you highlighted the lists, the X list is already going to be populated with column A. Do you see that? If you hadn't highlighted the list, this column A thing wouldn't be there. If you didn't highlight column B, that thing wouldn't be there. Everything's okay. It's all good. It's going to save the equation to the function f1. And so let's go ahead and get to OK. I know some of you like to use the arrow and the directional pad. I like to press the tab button. I'm gonna tab all the way down to OK. I'm gonna tab all the way down to OK, and then I'll press Enter, and it gives me all kinds of weird numbers. Do you see them? Now you probably should have got this for your linear equation. You should have got something like this: y equals mx plus b. So y equals my slope is this 0.5. What's that? 523. Let's just round that to 2 decimal places. What would that be? 0.52 x, and then my b value, that's my y-intercept, that's negative. So instead of plus minus, I'm just going to write minus 25 point what? I want to round it to 2 decimal places. 0.78. Okay. So that's my equation. That's my linear model that represents the situation. You know what this is saying, though? This is kind of weird. This is saying somebody that's 0 inches tall wears size -25.8 shoe. Let's think about that. Somebody who is 0 inches tall wears size -25.78 shoe. Does the model make sense for somebody who's 0 inches tall? No. So one thing we talk about in advanced math is intervals. This only makes sense for people who are of a certain height. Does that make sense? You with me? Okay. So if we were to sketch this in the regular Cartesian plane, what's going to happen is somebody who's not tall at all wears a size -25 shoe, and that doesn't make any sense. And we know that this has a positive slope. And so what happens is for all these people down here, they're still in their mama's womb, right? They're still being, what's that word when you're being developed, when you're developing? They're still developing inside the womb, right? And then what happens? By the time you come out of the womb, you're a certain height, and you have a certain shoe size. So there's only a certain interval, there's only a particular interval for which this information makes sense. You picking up what I'm putting down here? Okay, we're almost done. I want to answer 2 questions then. Number 1, I want to find out, based on this model, what shoe size would a 5-foot tall lady wear? And this is based on this model. This is all based on this model, based on this model, based on this particular set of information. What shoe size would a 5-foot tall woman wear? Now, what happened, I don't know if you guys noticed, when we ran that regression, did you see where it saved the equation? I mentioned it just in passing, real briefly. Our equation is f1 of x. I don't know if you noticed that. So what I can do is I can insert a calculator page. Let's see if we can insert a calculator page. Insert a calculator page. Let's insert a calculator page. How do we do that to our document? Doc, good. And then insert, and then calculator, awesome. Notice that all of these tabs have 1s at the top. Do you know what that 1 means? It means it's all the same problem. Problem 1, page 1, problem 1, page 2, problem 1, page 3. You with me? Okay. So the function f1, oh, did you see when I typed that 1 how it went from italicized to not italicized? Watch this. Here's an F, and it's italicized, right? But watch when I type the 1. Do you see how it turned bold? It's because the calculator says, you know what, dog? I'm ready for you. I can do this because I know that F1 of x is that equation that we just found. So we're going to evaluate that for a specific value of x. If somebody's 5 feet tall, what's their x value? Be careful. It's not 5. Remember, we put the height in what? In inches, right? 60. 60. So a 5 foot tall person, remember that their x is 60, right? So we're going to evaluate this function for 60. And based on this model, what size shoe should that person wear? 5 what? Now here we got to think a little bit. Can we go to Kohl's and buy a size 5.64 shoe? It's 5.5 or 6. Chances are they might not even have 5.5s. So we'll probably have to go to a 6 or 5.5. If 5.5s are possible, probably 5.5. Does that make sense? Sometimes you have to use your brain a little bit. Sometimes you have to make inferences. Sometimes you have to think and realize, you know, I can't buy a size 5.6 shoe. One more thing and then we out. Based on this model, what size shoe would a 8 foot tall lady wear? Oh my gosh, no, no. I asked the question wrong. I'm sorry. Can I neck myself? Can I do this? Did you hear that? I necked myself. I don't want to know what size shoe they want to wear. I want to know how tall is a lady who wears size 21 shoe. Wow, dude, she's going to be like gigantic. Shaquille O'Neal. So you might start plugging in some things. You might start plugging in F1 of. So a 6 foot tall woman wears size 11. But we want to kind of go the other way with this. We want to know, when does F1 of x equal 21, right? There's a little trick you can do on your calculator. Isn't this an equation? Did you know that the calculator is capable of solving equations for you? You can type NSolve, parenthesis, F1 of x equals 21 with a comma and an x, and it'll solve that for you. This is so cool. Today I should be selling like 20 of these calculators to you all. I should work for Texas Instruments. So we're going to type that, NSolve, the letter N, the letter S, the letter O, the letter L, the letter V, the letter E. Notice how it went from being italicized to a command that says, dude, I'm ready for you. Dude, I can numerically solve this. All you got to do is type in this equation, and the equation is F1 of x equals 21. Solve that for x for me. Anybody got him? Anybody got him? I'd imagine it's going to be like 80 or 90 something. Anybody got it? If your F1's not showing up bold, then you didn't run the regression. And if you didn't run the regression, it's not going to work. You got it? What do we got? 89 sounds about right? So 89.35. So let's think about that. So x is 89.35. So this lady is 89.35 inches tall. But how many feet and how many inches is that then? Let's think about that. We know 6 foot 72 inches. We know that 7 feet is 84 inches. So how tall is this lady? So what's our answer? How tall is she? 7 foot what? 7 foot what? 7'5". About 7'5". That's a big lady. That's taller than Lisa Leslie. Did you learn something about the calculator today? Did you learn what happens to the magical tractor today? Do you know about fruit flies? You've heard the phrase, you know, the older you get, the faster time. No, the older you get, the slower time. Wait a minute. The older you get, the faster time goes. Time flies like an arrow. Fruit flies like a potato or a banana. Time flies like an arrow. Fruit flies like a banana. Maybe my jokes are too bad today. Perhaps I should tell you about the theatrical production I'm writing about puns. It's really just a play on words. It's been real. It's been fun. I hope you had a good day. Hope you learned something. See you next time.
Good.